Alright, in these next couple sections, we're going to start looking at some more introductory terms. The first section, that 1, 1, 1, 2, and 1, 3, we kind of got going into points, lines, planes, rays, angles, all these basic geometric shapes. And we're going to continue that through these next couple sections, looking at just introductory material. Now, we're not going to go into a lot of depth. Like, for example, we've got another whole unit that's going to take us about 2 or 3 weeks later on in the year on polygons. Same thing with triangles. Triangles are going to take us about 6 to 8 weeks. And so we're just briefly looking at some basics right now. And then we'll take this basic knowledge and we'll expand on it later throughout the year. So the first section that we're going to look at is polygons. And these are some examples of polygons that we have around the outside. And again, a lot of this is going to be vocabulary. I'm going to go through it fairly quickly. If you need to, pause the video while you're taking notes. All right, a polygon. Big thing about polygons is that it has to be a closed figure. Okay? It has to be a closed figure. And it's formed by 3 or more. Sorry about that. It has to be formed by 3 or more segments. Okay? So it's a closed figure in a plane, and it's formed by 3 or more segments. Okay? Each of these segments is called a side, and each of the endpoints is called a vertex, just like in the angle. And these are just some examples of different types of polygons. Here's an example of things that are not polygons. We'll kind of go through each example and talk about why it's not. This first one, there's no segments there. It's a curve. So any kind of a curve, oval, ellipse, circle, none of those things are polygons. On this next one, it's not a closed figure, so it doesn't count. The heart down here, again, it's got a curve. This next figure's got a curve. We've got an angle. It only has 2 sides. Has to have 3 sides. And then notice on this last one here, the sides intersect, so that would not be a polygon. All right, we've got some different parts we need to talk about. We talked a little bit about what a side is. So, for example, AB is a side. We talked about a vertex, which would be, for example, angle B. In these next couple, you might have seen these terms before, consecutive. You might have seen that in an English class or something like that. All that consecutive means is it's right next to it. So, for example, consecutive sides would be like these 2 purple arrows are pointing at here. Side DC and side CB are right next to each other, and so that's why they're consecutive. Then we've got consecutive angles. So, for example, these green arrows are pointing at consecutive angles. Angles E and angle A are right next to each other, so they're consecutive angles. E, A, and B would be an example of 3 consecutive vertices. All right, now classification polygons. We classify a polygon by the number of sides that it has. These are the names and the number of sides that you're expected to know. I'm not going to go through and read them all. You can do that. You need to pause the video, write down the ones that you don't know. Because I might ask you to draw a nonagon. You got to know how many sides I have. I might ask you to draw a pentagon. Again, you got to know the number of sides. So whatever ones you don't know, get down. A couple things about these last 2. Anytime we get above 12 in our class, we're going to call that, however many sides it has, that many sides gone. So if it's got 13 sides, it would be a 13 gone. If it's got 27 sides, it would be a 27 gone. For our purposes, that's what we're going to call anything over 13 sides. They do have special names, but we're not going to go that far into it in this class. Future classes we might, but not right now with us. Alright, a diagonal, we're going to look at a couple different parts. A diagonal is a segment that connects 2 vertices that are non-consecutive vertices. So, for example, what we've got here, this last blue line, this is a diagonal. And sometimes we'll talk about all the diagonals that we can draw through the figure, sometimes in just one vertex. And I'll let you know about those when we get to those. Alright, a convex polygon. A convex polygon has no diagonals outside the polygon. I think an easy way to look at that is to look at some examples. So these are convex polygons. Notice all the diagonals are here in purple. Every single one of them is on the inside. Another way that you can think of it is that all of the angles point out. So if I look at all these angles, Every single one on this 1, 2, 3, 4, 5, 6, this hexagon, all of them point out. So that lets us know it's convex. The second type of polygon that we're going to look at is concave. And a concave polygon has at least one diagonal that's outside. So for example, these orange segments here, these are all concave polygons because we have at least one diagonal outside. Another way to think of it is you could think of it as being caved in. So for example, on this one, it looks like it's caved in here. We've got two of the vertices pointing inside towards the middle of the figure. Perimeter, you should have done this before, probably since 5th grade, talking a little bit about perimeter just to make sure that we all remember what it means. It's just the sum of the lengths of the sides. So if I add up all my sides, I got 15 and 5 is 20, 20 plus 12 is 32, plus 6, which would make our perimeter as 38. Make sure that you use your units. I will take off points if you forget your units. We've got to get into that habit because you will need to do that on your AP exams when you get to calculus and maybe even if you take stats. You're going to have those little bitty things. It's kind of like we talked about in class the other day. Make sure you get used to putting all the details. Alright, now we've got an equilateral polygon. And a lot of our terms in geometry, you can kind of just break down the terms and I'll tell you exactly what it is. Equa, just like equal. Lateral would be side, so it means same side. Polygons with all the same sides. Equal angular, the equa again is equal, angular, angle, so the polygon has all congruent angles. And then finally the last one is a regular polygon, it has both. So all congruent sides, all congruent angles. Alright, now when we talk about two polygons being congruent, they have to have exactly the same size and the same shape, and all the corresponding sides must be congruent. So for example, note that's going to be the name of two of our polygons. So I'm going to show you these pictures. So here's one, and here's the other. Here's polygon camp, C-A-M-P. Now, whenever we name polygons, and I'm glad this showed up here, whenever we name polygons, we just need to go in order of the letters. If you go in clockwise or counterclockwise, it doesn't matter. But as long as you go in order, so if I started with the A, I would need to go around one way or the other. And then finally, this last one, site. We've got our polygons that are congruent. Think about the name of this one. I'll tell you here about before we move on the side. Think of the name of that shape. A couple things. Notice the markings that you know which sides are congruent, that you know which angles are congruent, and notice that the letters match up. The C is congruent to the S because it has 4 markings here, 4 markings there. The C and the S are in the same position in the name. That lets you know which angles are congruent. And then these figures are trapezoids. Alright, last thing for you to do, and I want you to make sure that you do this on your own, because this is what we're going to start class with, is this little construction problem. Alright, it says use any of your geometry tools, so you can use a compass, straight edge, ruler, protractor, whatever tool you can use to create this pentagon. It needs to have 2 consecutive sides of 4 centimeters and 3 consecutive angles that are all 100 degrees each. So I want you to think about how you would do that, come up with some strategies, and I want you to actually come up with one of these pentagons. And I'll call in about 3 or 4 people. We'll talk about, and we'll get into a discussion on how we created it, some different strategies. We'll compare the strategies around the room to kind of see if anybody has one that maybe is a little bit easier or more difficult than others. And maybe some little tips that we can use. Because we're going to be doing these things throughout the year, constructing these different figures and looking at some properties that they have. Okay, so make sure you do this tonight, and we will discuss that tomorrow. And that's the end of our notes for this section.